Okay, so chapter 12 involves sequences and series. Trying to remember, they've revised the courses both for pre-algebra and algebra 1. But I'm thinking your class would have had sequences in both arithmetic and geometric and pre-algebra. Think you would have had the new book by then. You definitely had it in algebra 1. Interspersed throughout every chapter, there was a section that involved sequences that we dealt with. So some of this should be a review of that and a refreshing of your memory. ACT, SAT, usually good for a couple questions about sequences and series and really understanding the inner workings of them. Definitely good for a question on summation, and we'll get to that a little bit later in the chapter. So all this first part should be review, and I'm just going to go kind of quickly, but stop me if you need me to, and I'll give a little bit more detail. What's a sequence? It's basically a set of numbers in an order, right? And the order is a distinguishable, what would you stick in there? Pattern. So you got a distinguishable pattern. Now I will say this, depends on who the person is, whether they think it's distinguishable or not. And some patterns are more distinguishable than others. The example, I think you can catch on to the pattern, right? So you got 1, 4, 7, 11, and the next number must be? 14. Very good. 15, right? Because you're adding 4 to the Whoa. What in the world? Fix that. Good night. No wonder. That's great. First edition notes. I love it. That should have been a 10. All right. I think I can add, but then again, sometimes you just wonder. All right, so 1, 4, 7, 10, 13, and on we go, right? Should be the idea. If the sequence goes on to infinity, then it doesn't take a rocket scientist to figure out that it's an infinite sequence. An infinite sequence. It goes on to infinity, and this one goes on to infinity, and maybe even beyond. All right, so an infinite, I-N-F-I-N-I-T-E, infinite. And so if it's not infinite, it must be finite, right? Finite means a distinct set amount. Infinite goes on forever and ever. And what do you call the 3 dots? Ellipses, right? E-L-L-I-P-S-E-S. And just, look, this is elementary, but I just want to make sure that we've got it down. You're supposed to give 3 numbers in the pattern before using the 3 ellipses. Therefore, then the person looking on can distinguish the pattern and know how it goes on forever and ever. So it takes 3 in the pattern before you use your 3 ellipses, and onward you go. All right, each number of a sequence is called a term. And terms are identified by a subscript. Terms are identified by a subscript. And you know, all I mean by that is simply this. If I want to talk about a sequence, I can give it a capital letter. So that, for example, I say I'm talking about sequence A, or sequence Z, or sequence Q, or sequence R. So then if I want the 4th term of sequence R, I use lowercase r with a subscript of 4. The 4th term of the R sequence. That's all it is. It's not a big deal. So a couple examples here. You know, obviously you got sequence A and you got sequence B. So A sub 2, this is really difficult, but believe it or not, that's a 9. And what you guys should understand from the beginning is the 3 is the first term, the 9 is the second term, the 15 is the third term, the 21 is the fourth, etc., etc., etc. And same with the B sequence. The 1 is the first term, the 2 is the second, the -1 is the second, and the -5 is the third, and on and on and on and on we go. I did it on purpose, one with braces and one without, because you'll see it both ways. So don't let it throw you off, not a big deal. So obviously A sub 2 is 9 and A sub 3 is 15, and if you follow the pattern, A sub 5 would be, and these are pretty easy in that aspect, right? Not a big deal. I don't think we even need to. Well, let's just do b sub 4. So what's the fourth term of that sequence? All right, and hopefully you think it's negative 9. 3 minus 4 is a negative 1. Negative 1 minus 4 is a negative 5. And negative 5 minus 4 is a negative 9. Not a big deal. Can I mention this, though, as well? If you want to think of it this way, you can think of this as a set of ordered pairs. Where if you look at the A sequence, where if the input is 1, the output is 3. And if the input is 2, the output is 9. If the input is 3, the output is 15. The input is 4, the output is 21. Where the number of the term then has an associated value with it, so they're paired up, and you can think of them as an ordered pair. So you can think of them as x and y's, where the seventh number in the sequence would be the 7 value on the x-axis, and therefore then it's out what it is would be the output, the y value. So you can think of them as a set of ordered pairs. All right, there's a couple different types of formulas, and they have a couple different names to them just to confuse students because we like doing that. But the first one is the explicit formula. The explicit formula. E-X-P-L-I-C-I-T, the explicit formula. It's really the more valuable in my estimation of the two types of formulas. And it's more valuable because it'll allow you to find the value of any term. Because you basically have a variable there, and all you got to do is stick in the number of the variable, and away you go. All it takes to understanding the explicit formula is to realize what n is, right? N simply equals the term you're looking for. I don't know how to say this. I'm just going to say that term. You'll see what I mean in a minute. So it just simply means that term. So if we were looking for the seventh term, then I would go a sub 7, because n is 7. I want the seventh term, so a sub 7. And now it's just elementary sub in value, right, where the n is. Stick in the value then, and what are we looking for? An n of 7. We're looking for the seventh term. So now the rest is just elementary, and what do we get, 11? So the seventh term is 11. And the explicit formula will give you any term you want. You know, if you want the 100th term, okay, great, it's 197, right? You want the 1,000th term, okay, it's 1,997, right? You want the millionth term, it's 1,999,997, right? Just sticking in that value for the n, piece of cake. So again, the second example would be b sub 11. Go ahead and finish that off. Go ahead and find the 11th term. 11th term. So again, if we say the 11th term, n is 11, piece of cake, 46, I hope. And that's all there is to that aspect. So explicit formula, real valuable. It's going to allow you to find the value of any term of the sequence. No matter what the term is, you can find it if you have the explicit formula. Those were both arithmetic sequences, and those are pretty simplistic. The last couple are a little bit more interesting. So go ahead and do C and D. Go ahead and do C and D. So fifth term of the D sequence and the 20th term of the K sequence. Yeah? Yeah. 762, second one, you like? Trying to do it in my head, challenging my brain, keep from getting Alzheimer's. Oh, yeah. Do math teachers get Alzheimer's disease? Don't think so. They have to think too much. All right. No, I wouldn't be a blanket statement, but it helps. All right. So negative 26 and 762. Everybody okay with that? Generally, we don't ask you for a negative term, like what's the negative third term, because that's not really the idea of a sequence. So usually a negative out in front isn't a big deal. It's not like you have negative and negative or anything like that. All right, but when you get to E, now things get a little bit more interesting. Write the explicit formula for the sequence 3, 5, 7, 9, 11. All right, this is inductive reasoning. Look, I can't, in a kind of problem like this, I can't say, all right, class, step number 1, think this. Step number 2, do this. Step number 3, do this. There's an infinite number of variations. And therefore, you have to think. Now we're in a little bit of trouble, especially judging from the lab that we just had. We're in a little bit of trouble. Which, by the way, that reminds me. I just meant to say this then, and I forgot. It just killed me to watch you guys with your angle indicator. It really did. So this is what I saw when people were citing. No lie, this is what I saw. People were citing. Oh, dude, 70-something. Right? What's wrong with this picture? What's wrong with the picture right now? Yeah, the plumb bob is weaving and bobbing and weaving, right? So that, first off, that's wrong. And the other thing I saw is even people that were careful to, all right, stop the plumb bob. And then they did. This is also what I saw. Now, remember, you got like 6 or 7 other people standing around doing nothing. And this is what I saw. The person doing something like this. They're like this. I'll put the thumb there. When you got 7 other people standing around that could be reading this stupid thing. So he doesn't have to move and he's just citing it and the other person's reading it. All right, so that makes you feel bad. It should. All right, you had 7 guys there to think. And I think one group maybe had somebody looking at it, maybe 2. Definitely at least 2 did not. All right, anyhow, it just made me think of that. Inductive reasoning. You do have to think. All right, so these can be a little difficult. I will tell you this. If you were in a situation where you did 50 of them, you would begin to see a couple of the types and begin to get a better understanding, or you'd remember, oh, this one might be like that one, and therefore I'll try to do what I did on the other one, and it'll work. But we're not going to do 50 of them. So it's going to be a little bit harder on you because we're not going to do a ton of them. We'll do a few. So write the explicit formula for the sequence. Again, when you see that word explicit formula, you are thinking a formula that allows you to find any term of the sequence. So there's going to be an a sub n, and it's going to equal some numbers with one variable in it, and that variable is going to be n. And that has to give you the value of the first term, the second term, the third term, the fourth term when you put in that value for n, right? Put 1 in for n, better give you the first term. Put 2 in for n, better give you the second term. Put 3 in for n, better give you the third term. Put 20 in for n, better give you the 20th term, right? That's the idea of the explicit formula. Some think it helps to label their positioning. I'll use the first term, second term, third term, fourth term, fifth term. And the reason some think that helps is because, remember, that is the value of n. Right? N is 1 for the first term, and n is 2 for the second term, and n is 3 for the third term, and some people think that helps them to be able to write the explicit formula. But again, this is an inductive reasoning situation, so it takes some reasoning skills, it takes some thinking skills. For some of you, this is going to be way harder than for others. Don't get mad at the people that see it right away. Remember, to whom much is given, much is expected. So, and there is always the curse of having, a quick deductive thought. For example, now you guys are young, but older people that are good at their deductive thought will look at our country and look at the economics and look at all the other stuff and say, oh boy, things are really scary right now. All right. Whereas other people that don't deductive think, they just go happily through life, sailing through because things are grand, things are great. All right. Anyhow, did you find the explicit formula? Did you find the explicit formula? Does it work for every term? And I will say this. Would you agree that 5/10 equals 1/2? Would you agree? Yes? All right. Would you also agree, don't write this, but let's say I had the equation y equals 7x plus 4. Would you agree that 3y equals 21x plus 12? Would you agree? You should, because they're exactly the same. The second example is 3 times every value, and if you were to solve them, you'd end up at the exact same place. They are different forms of the exact equation. So it is possible that you thought up something that technically is true, maybe not the base form. So that's also possible. There's more than one form on all these, and that's what I was getting at there. All right, so anybody want to go for it? Luke, what do you got? 2n plus 1? So let's check out Luke's theory. If n is 1, we get 2 plus 1 is 3. If n is 2, we get 4 plus 1 is 5. If n is 3, we get 2 times 3 is 6, plus 1 is 7, and 4 would work and 5 would work. It works. Do you agree? Did anybody have anything different? Anybody have anything different? I've seen people try stuff like n plus 2, but you'll see on the second term that one doesn't work, does it? Right? Because, again, all right, it works good the first time, 1 plus 2 is 3, but then put a 2 in for n, 2 plus 2 is not 5, and you're off. And you can play around and stuff, but that is the explicit formula. Anybody else get it? A few of you? All right, and again, look, so let me go through this spiel one more time. Be like my last chance, because I won't see any of you guys ever again, probably, in your math career, probably. Of course, you never know. You just never know. I'm just saying, you never know. But if things go as they are, I'll never see you again. You got to think, though. And especially those of you that go on to advanced math next year, and especially calculus as a senior, if you just sit there and don't think, of course you're not going to figure it out, and you're not going to get anywhere. All right, so that's that one. The second one I think is definitely more tricky. Again, if you want to go through and number n, and it's definitely going to be a sub n. See if you can figure out the explicit formula of that one. I'll pause. And as I said while I had it paused, the first one's an arithmetic sequence. Before I get to the second one again and we analyze it all, let me mention one other thing. If you were to graph that, what kind of shape, don't say anything out loud, what kind of shape would the graph of that be? Again, the x value would be the number of the term, first term, second term, third term, fourth term, etc. But what would be the shape of the graph of that? All right, if you've got an idea on 3, tell me your answer. 1, 2, 3. That's scary. All right, that is so scary to me, especially how much things have been emphasized. I think on every exam you guys had that. Doesn't that fit that pattern? What kind of shape is that when you graph it? So that's going to be a line too. It's linear. Variables to the first power. Okay. The y-intercept would be 1. The slope would be 2. And that thing is a line. All right. That's scary. All right. But again, so you got to think. You have to make connections. That's the key to everything. Okay. So this second one. Elias, you're the only one that had a thought here. What do you want to try?
I think I had it wrong.
Okay, anybody? Abigail?
A sub n equals parentheses -3, so parentheses to n.
-3. Wait, you're concussed. You're not supposed to come up with anything. Let's see if her way works. -3 to the first power, -3. -3 squared, -3 times -3 is 9. -3 cubed, -3 times -3 is 9 times -3 is -27. -3 to the fourth is 81, etc. That is the explicit formula. A to the n equals the quantity -3 to the n. Just so you guys understand, if it alternates positive and negative, you have to have a -1 to the n. It's the only way you're going to get it to alternate positive and negative. And then this one, to get the rest, you needed a 3 to the n. And let's see, how should I do this? I don't know if I should do it that way. Anyhow, I probably shouldn't put them together because it's not like they're not the same base. But basically where you end up then is -3 quantity to the n. Do you need that parentheses around the -3? And the answer is yes, because this, whoops, this, come on, pen, this is not the same thing. All right, say that's tricky. Yeah, I know. I told you in the beginning it was tricky. And again, what you got to do is you'll learn some things. So hopefully on this one you learned to alternate. We've got to have some -1 to a power, and therefore we're going to have a base to the power, and away we go. All right, number 2. The more simplistic formula is the recursive formula. Recursive. R-E-C-U-R-S-I-V-E, the recursive formula. And this one describes the sequence in respect to the first term. So it describes the sequence in respect to the first term. I'm sorry, I'm thinking first term's in a previous term, my bad. Previous, much better. So it's going to be in respect to the previous term. The first term's involved in the formula, but it's in respect to the previous term. All right, just to be clear, whenever you have the previous term, the subscript of it is going to be, get my pen back, the subscript of it is going to be an n-1. Because we have to use variables, and this might be confusing to some, but hopefully we'll do it enough to where you get it. But let's, for example, say we're talking about the 7th term. So n would be 7. In variable form, the 6th term would be n-1. 7 minus 1, 6. The previous term, right? If 8 is the term we're talking about, the previous term is the 7th term. 8 minus 1, n-1, the 7th term. So again, how do you say the previous term? n-1. That's all I'm trying to say there, is that the notation, like you see right here, that means the previous term, all right? n-1. All right, that's the concept, that's the idea. And then the other thing with this formula, and that's why it's not that big of a deal, because it's limited. You use this formula to find a term if you know the previous term. If you don't know the previous term, you can't use this formula. It doesn't give you anything. You're not going to be able to find the term unless you know the previous term. Okay, so if a sub 1 equals 5, then we got to go ahead and figure out the sequence here. All right, so let's see if we can figure out what we're doing here. Okay, so if a sub n is 5, a sub 1 is 5, I'm sorry, let's see, how do I want to go through? Let's write the first 5 terms. All right, first 5 terms. Okay, so let's go a sub 2, second term. A sub 2. It's going to be -4. Use a parentheses and then put the -7. So all I have is the exact same thing ahead of me, right? I've got -4 where the a sub n-1 was. I put a parentheses and then I put -7. All All right, here's a thought. A sub 1 is 5. If I'm doing the second term, what's the previous term? The first term, and what's the value of the first term? 5, so the 5 goes in there. Okay, so to do the second term, I need to know the first term. The first term, a sub 1, is a 5. So again, the previous term to the second is that a sub n minus 1. All right, so what do we end up with is just simple math from here on out. Negative 20, negative 27. And that is the second term. And now you just keep working your way across. So now I can do a sub 3, right? So again, stop me if you need to. Ask a question if you need to. A sub 3. So we got our negative 4, parentheses minus 7. And what are you going to stick in the parentheses? Negative 27, right? Now the previous term to the third term is the second term. And you just keep walking this all the way. Oh, excuse me. So a sub 3 on this is 101. Right? Is that right? 101. 108 and 7, 115. Right? 115. Is it 101? What? Why is my... Oh, because positives and negatives. Okay. All right. It's like, what in the world? Now, it's one of those days. Brother. All right, and then you just keep working out. A to the fourth. And same thing, negative 4. And now we know the previous term, which is 101. Hey, this one I can handle. I was watching a teacher forum, and one teacher said they have a jar on their desk, and every time they make a mistake, they put something in. I can't remember what it was, like a jelly bean or a penny. And when it fills up, the class gets a pizza party or something, she said. Or he said, and the teacher said, well, they always know that they're getting a pizza party. So anyhow, such is the life of teaching math. All right, what's that? Negative 404 and a negative 7, negative 411. Is that one good? All right. And then if you finish the last one, you know, again, you're going to be somewhere in the neighborhood of, I think, 1,600. For time's sake, I'll quit there, but you get the idea. So because I knew the first term, I could get the second. If I knew the second, I could get the third. If I knew the third, I'd get the fourth. If I knew the fourth, I can get the fifth. If I know the 10th, I can get the 11th. If I know the 77th, I can get the 78th. You'd hate to have this formula and somebody said, find n sub 37. Because you got to do this 37 times. What a pain. And that would really, literally drive you crazy. All right. Let's take a look at this. So you got a sub n equals a sub n minus 2. Uh-oh. The previous term. Previous. See, like that. All right. So let's take a look at something and see if we can figure some things out. I'm just going to start to write the sequence all the way over here to the right. Would you agree the first term is 1? Because a sub 1 is 1, right? And a sub 1 is the first term. Everybody okay with that? Right from here, it said a sub 1 is 1. And the second term is? Because a sub 2 is 1. Okay? So now we're ready to find the third term. Do you agree? So we can find a sub 3. Again, I put 3 in for the n, right? Third term. Don't let the variables drive you crazy. It's pretty easy. N is the term you're looking for. So what is a sub n minus 2? 3 minus 2 is 1. What's a sub 1? What's the first term? 1. What's the n minus 1? 3 minus 1 is 2. What's the second term? 1. Therefore, a sub 3 is 2. Ooh. So the next number, all right, so let's do this one more time and then we can just do the pattern. So the fourth term, n minus 2, two previous terms to the fourth is the second. What was the second term? 1. And we have to add to that the third term. And what was the third term? 2. So this term is a 3. So we can go right off the sequence now, right? 1 and 1 is 2. 1 and 2 is 3. 2 and 3 is, right? I mean, you can use the formula if you want. So that's 1, 2, 3, 4, 5. Do the last two terms. And hopefully you said 8, and then you said 13. And then you said Fibonacci. Whoa, cool. We are in the world of Fibonacci. All right. You can Google Fibonacci or go on Khan Academy and watch what's her name do all her great Fibonacci videos. A bunch of you guys would have seen those in Algebra 1 or Algebra 2 when people were gone. If I had time, I'd love to show. I might have time here at the end, show a little bit of Fibonacci. All right. By the way, this thing keeps going. The next number would be 21. The next would be 34, and you can keep going forever and ever and ever. But this is the recursive formula of a Fibonacci sequence. There's also an explicit formula, of course, for a Fibonacci sequence. By the way, that's not the only Fibonacci sequence. That is the main one, but again, you can start with 2, 2, and then go to 4, and then 6, and on you go, right? I mean, those numbers, the way you start. Again, add the previous 2. Okay, write the recursive formula of sequence. Again, here we are now. Again, we've got to do this inductive thinking. And again, in a lot of people's minds, numbering the terms can help them out. And this one's simplistic. This one's not hard. But again, you got to try to write an explicit formula. And the explicit formula doesn't always have to have an n minus 1 in it. It can have an a sub 1 in it, which really is easier in some cases depending upon the situation. So this thing happens to be arithmetic. If you look at your gaps on this, that's a 5 gap, and that's a 5 gap. Anybody come up with a recursive formula? No, you're concussed. You can't give us both. Come on, somebody else besides the poor concussed girl. Give me a formula. How about previous concussed? Come on, get in there. Soul sister. By the way, good to see you doing well, Abigail. Hunter?
A sub n equals a sub n minus 1 plus 5.
A sub n minus 1 plus 5. Or you can go straight to a sub 1 plus 5. Either way, this is more technical. That one will work as well. That was an arithmetic sequence. That was kind of an easy one. What will you have the hardest time with? It'll be with doing this kind of thing, trying to figure out the recursive or the explicit formula. And again, it's hard to tell you. Notice this one, I looked at the gaps. Arithmetic sequences, looking at the gaps can give you insight. Geometric, not so much. So it's different. They're different. You got to learn the different nuances. All right, I'll quit there.